Okay, so it's caught up with where they were yesterday. So, next we're gonna do unit vectors. Okay, what's the formula for unit vector from your notes yesterday?
V over magnitude.
Okay, good, so take the vector and you're gonna divide by the magnitude. So you're gonna be given the vector, so what you're gonna do is you're gonna have to find the magnitude first. Okay, so if I'm given the vector is negative 2, 5, how do I find its magnitude? What's the formula for magnitude?
Q1, log square root.
Okay, so do square root. So it's already in vector form, so you just square the first number plus square the second number. Add them together. So 4 plus 25 is 29. Okay, is 29 a perfect square? That should be an easy answer, yes or no? No. Okay, I can't break it down because it's a prime number. So the formula says you're going to take your vector, so it's my vector, and I'm going to divide by the magnitude. So I'm going to take negative 2 divided by square root of 29 and 5 divided by square root of 29. Now, if you could simplify, you would simplify, okay, but you can't simplify numbers and square roots, so you're done. On vectors, you do not have to rationalize the denominator. But if it makes you feel better, because you've always had to rationalize it on everything else, and you want to rationalize it, you can. So I will accept this answer. But you do not have to on vectors. And those of you that are taking calculus next year, there's a lot of times you don't have to rationalize the denominators. Okay. So as long as you have your square root simplified, like you wouldn't want to leave like square root of 16, because that comes out perfectly before. But if it's not perfect, you can't simplify, you can leave it alone. So we'll do one as component form, and this one's a linear combination. Okay, so if I were to put this in component form, basically what happens is because I is the vector 1, 0 and j is vector 0, 1, I is like your first number and j is like your second number. So this is essentially 0, 4. Okay, this is component form, is when you have like the arrow or alligators, whatever you want to call it around it. Okay, this is non-component. Whatever it starts at, unless it tells you to go from one to the other, whatever it starts out, we're going to leave our answer in that. So the first thing to do is find the magnitude. So I want to do the magnitude of v. The square root, well, there's only one part, which is 4. So this is the square root of 4 squared. What happens when you take the square root of something squared? Cancel. So my magnitude is just 4. So if I want to find my unit vector, I take my vector divided by the magnitude. Okay, can you simplify 4j over 4? Yeah. So since that does simplify, 4 divided by 4 is 1, you would simplify that down, so this is your vector. If it makes you feel better to put in the I, you can put this. Yes?
How did you get from 4J to 0, 4?
Okay, because I is equal to this, and j is equal to this. Okay, so what happens is you would take your I number, which there's nothing, times this plus your j number times this, and this was gonna be what your, so this would be 0, 0 plus 0, 4, which is 0, 4. Okay, because these are ones and zeros, essentially your first number is your I, and the second number is your j. Okay, just a different way of writing it. But this is how they go from linear combination form to component form. So like if I wanted to do it over here, like if I wanted to put this in component form, this would be -2 times the vector 1, 0 plus 1 times the vector 0, 1. Which would give you the vector -2, 1, which is like the same if I just put this in the first and that number in the second. Okay. So these are special unit vectors that they already give to you. These mean this every time you see, and they're only when they're a bold case I and a bold case j. So it's not like imaginary numbers where they're not bold. Okay, does that make sense? I know it's weird, but does that make sense? Okay. Other questions on unit vectors? Okay. A little bit harder stuff. Oh, it's so terrible, isn't it? This isn't really that. Do you think this is hard?
Yeah.
Yeah? I feel like this is way easier. And I know like some of you weren't here at the beginning of class, so you might want to go watch the video from yesterday, which will explain how to do like the first couple. So I know you weren't in here yet. Okay, essentially the only three formulas you have are the component form, magnitude, and unit vector. So as long as you have those three formulas written down from yesterday, everything we're doing is just using those three formulas. So like for this section, we're going to find a vector v with a given magnitude in the same direction as u. Okay, I got asked second period, what's a unit vector? A unit vector is like the smallest portion of what you can break it down into. Okay, so this is not a good example of the best one I had. Like if you go out and run a mile around the track, okay, how many laps is that around the track? 4. A unit vector of that would just be 1 lap. Because what happens when you do it to 1 lap? You're tired, but what do you do after that? You go to another lap, right? Okay, so the unit vector is like the smallest version of what that is. The magnitude is what you're stretching it out by. So like the magnitude of like a mile, if the unit vector is 1 lap, you want a mile, your magnitude is going to be 4. Because you want 4 laps. Okay, I know it's not a very good example, but that's what's happening. A vector is just what direction you put it into. So like if I'm going to go this way, that whole way, okay, that's my direction, that's my vector. So I'm given the magnitude of v, and I'm given the direction of u. So if I want to find a vector v, that means I got to find what this unit vector is, and then I'm going to multiply by that magnitude of whatever, however long v says it is. So how would I find the unit vector of this, based on what we just did over here? What did I do? What's the formula say for unit vector? Faith, I know you know the formula. For unit vector? You just said that when we did it last time.
V over magnitude.
V over magnitude. Okay, V over magnitude. So if I have u, I gotta find the magnitude of u first, right?
Yeah.
So I gotta find the if I want this unit vector, I have to find its magnitude first. So the magnitude of u is the square root of 3 squared plus 3 squared. So square root of 9 plus 9, which is the square root of 18. Okay, 18 will break down. So if it breaks down, you have to break it down. So I can break it into what? 6 and 3. 6 breaks into 2 and 3. So that means my magnitude of u is 3 square root of 2. So what would my unit vector be, or how would I find my unit vector now? If you told me the formula is v over magnitude of v, how would I find my unit vector for u? So what do we do over here?
Is it like 3 over 3 square root of 2?
Okay, so 3 over 3 square root of 2. What's the other part?
3 over 3 square root of 2.
Okay. Can I reduce either fraction?
Yeah.
Yeah, the 3's both eliminate, right? So this would be 1 over square root of 2. 1 over square root of 2. Okay, this is the unit vector for u. The directions they were going to find a vector v with a given magnitude that goes in the same direction. So what's my magnitude for v? 5. Okay, so it tells me my magnitude is going to be 5. So this is my unit vector, and I want to find how big v is. And that means I take my unit vector and I'm going to multiply by the magnitude of v. So my vector would be 5 over square root of 2, 5 over square root of 2. And this is what your vector would be for v. Let's do another one. Okay, so I know my magnitude for v for this one's 9, and I know my direction for u is 2, 5. So the first thing to do is I have to find the unit vector for u. So if I want to find my unit vector, it's my vector divided by the magnitude, so I gotta find my magnitude of u. So how would I find my magnitude?
2 squared plus 5 squared.
Okay, so square root of 2 squared plus 5 squared. This would be the square root of 4 plus 25. Square root of 29. Then what would I do if I want to find my unit vector?
2 divided by 29.
Okay, so 2 divided by square root of 29 and
5.
5 divided by square root of 29. Okay, can you simplify that? Can I simplify these fractions? No. If you want to rationalize them, you can. You do not have to. Okay? So this is u, my unit vector for u. So how would I find v now? If I did what I did on number 7.
We use a 9.
Say what?
The magnitude is 9.
Okay, so what would I do with the 9? Multiply it. Okay. Okay, remember you're multiplying fractions, just multiply the top, so this would be 18 over square root of 29, 45. Now, because these start in component form, you're answering component form. If it started with i's and j's, then you're answering i's and j's. You okay? Alright, we're doing one more part today, and we'll finish the rest tomorrow. And these are bold i's and j's. Okay, so this is essentially like you're finding the component form. So like what we did like on the first couple of examples, but we're leaving everything as the i's and j's. Okay, so if I want to write this as a vector, how would I do that? I feel like somebody said it, but I didn't hear. Do I take initial minus terminal or terminal minus initial? Terminal minus initial. So I would have had, if this is component form, what we talked about in the first couple of examples, I would have had 4 minus negative 3, which is 4 plus 3, and 5 minus 1. So component form, this would be 7, 4. Okay, if we want to write it as a linear combination of i's and j's, this number goes with I, and this number goes with j, because I is equal to 1, 0, and j is equal to 0, 1. So this is really the vector 7, 0 plus 0, 4, okay, which is 7, 4. So if I want to write it as a linear combination, this is just going to become 7i plus 4j. There's no brackets, there's no comma, use plus or minus signs. I goes with the first part, j goes with the second part, and that's all you're doing. When it says write as linear combination, you're done at this point. There's nothing else to do. Alright, we'll do one more. Try this one on your own. Okay, so what'd you get as your vector?
3J.
Okay, so a 3 what? 3. And then you gotta have something else. 3I
8J.
plus 8J. Plus 8J. Okay? No arrows, no commas. This is what it would look like. So 2 minus -1 would be 3. We put the I with that. 3 minus -5 would be 8. So that gives us our J. So this is our linear combination. Alright, I'm going to stop there for today.